Hey everyone, and welcome to this explainer. Today we're diving deep into the Junos OS, and we're going to completely demystify its routing capabilities. If you've been looking to really transform how you understand, configure, and ultimately scale your Juniper networks, well, you're in exactly the right place. We're going to break down the highly modular architecture of Junos and then translate all that theory directly into actionable configuration and troubleshooting steps.
Here's our quick roadmap for the explainer. We'll start inside the routing engine, move into isolating with routing instances and the basics of static routing, then we'll scale up with the power of dynamic protocols, and we'll finish up by configuring and troubleshooting those elements. Let's get right into it.
Section 1. Inside the routing engine, the brains of Junos OS.
Okay, so to truly master Junos, you've got to understand its core, right? The routing protocol process, or RPD for short, is the absolute heartbeat of Junos routing. Because Junos is built to be highly modular, the software functions are totally separated. That means all routing protocol packets coming from the network are directed specifically here, to the RPD. And why does this matter to you? Well, it means that heavy, complex protocol computations don't unnecessarily delay the actual forwarding of your network traffic. Basically, the brain thinks, so the muscle can just keep moving those packets without breaking a sweat.
Here's how that relationship actually flows. The RPD evaluates all the available paths and determines your active routes. It then takes those and installs them directly into the routing engine's forwarding table. From there, the Juno OS kernel copies this table down to the packet forwarding engine. It's this beautifully clean, efficient one-way push from the brain down to the brawn, and that ensures your router scales perfectly without choking on control plane traffic.
Moving on to Section 2, isolating with routing instances, or, as I like to call it, taming network chaos.
Once your network really starts growing, unmanaged management traffic can create absolute chaos. I mean, it gets messy. The solution here is the MGMT_Junos VRF instance. You can think of this as a private VIP lane built exclusively for your management traffic. By default, management interfaces just sit in the default routing table, sharing space with all your protocol and control traffic. But when you configure this reserved, hard-coded MGMT_Junos instance, your management traffic gets its very own secure, completely private IPv4 and IPv6 routing tables. It's a real game changer for organization.
Now, before you go applying this VIP lane everywhere, there's a crucial catch you need to be aware of. This non-default VRF explicitly supports interfaces like EM0 and FXP0, as well as the Virtual Management Ethernet, or VME interface, which you'd use for managing virtual chassis. But it deliberately does not support other management interfaces like EM1. Oh, and here's a massive takeaway. Once you isolate your management interface into this MGMT-Junos instance, you cannot configure dynamic protocols on it. It is strictly a secure, isolated manual path.
Which brings us nicely to Section 3, the basics of static routing, the manual path.
So, because we literally can't run dynamic protocols on our new management instance, we've got to route to it statically. When you deploy that MGMT_Junos VRF, you have to manually migrate any static routes that use the management interface as a next hop. It's a pretty straightforward process, though. First, you run a quick show interfaces interface name terse command to find the exact IP of your default management interface, which again is usually FXP0 or EM0. Then, you simply add those specific static routes directly into the MGMT_Junos VRF. If you skip this step, you might actually lock yourself right out of out-of-band management, and nobody wants that headache.
But let me pose a question to you. Static routing is fantastic for a dedicated management port, sure. But what happens when your production network needs to scale dynamically and negotiate loop-free transit across hundreds or even thousands of links? You certainly aren't going to sit there and type all of that in by hand, right?
That takes us to Section 4, the power of dynamic protocols, scaling the network.
To scale a network dynamically, Junos natively supports the absolute heavy hitters of routing. For your external routing, you've got BGP, an exterior gateway protocol. It guarantees loop-free exchange between autonomous systems and, especially when you pair it with Junos routing policies, it's your go-to tool for enforcing peering and transit agreements. Then, for internal routing, you have two amazing link-state interior gateway protocols. There's OSPF, which uses the shortest path-first algorithm developed by the IETF, and then there's ISIS, which uses the exact same Dijkstra algorithm, but was implemented in Junos specifically to tackle issues of massive scale, fast convergence, and high resilience.
All right, Section 5, configuring Junos routing elements. Let's get hands-on with the CLI. We've covered the high-level macro theory. Now let's actually roll up our sleeves and look at the command line. For anyone out there migrating from a Cisco environment, Junos is going to feel like a bit of a paradigm shift. It uses a highly structured, very hierarchical approach. So instead of a simple flat IP route command, Junos nests it logically. Set, routing options, static route. And just look at how it handles OSPF. Instead of defining networks and wildcards sitting under a router process, Junos simply assigns the specific interface directly to the OSPF area using set protocols OSPF area interface. Once you see the hierarchy, it is remarkably clean and honestly incredibly intuitive.
Let's look at how that OSPF logic actually plays out in practice. Here we see a line set protocols OSPF area 0.0.0.0 interface loopback.0 passive. In just one clean, readable line of configuration, you've tied your loopback interface right into backbone area 0, and you've marked it as passive so it doesn't just broadcast hellos everywhere. The next line does the exact same thing for a fast Ethernet interface. Because it's so readable, it heavily reduces those accidental configuration errors we've all made.
And this hierarchical logic extends perfectly into advanced BGP policy routing too. In Junos, you first set up your core routing options, things like your router ID and your autonomous system number. Then you construct your BGP group, define its type as external, set the peer AS, and establish the neighbor IP. But the real magic, that happens at the bottom with the policy statements. Junos allows you to craft incredibly granular route filters to add specific communities or accept precise prefixes. You're literally manipulating route characteristics here to strictly control which routes become active and get placed in that forwarding table we talked about earlier.
Now, regarding these complex BGP policies, there's a feature you absolutely have to know about: the dynamic database. Standard configuration commits can sometimes take a while because of massive verification overhead. But with the dynamic database, you can configure your BGP routing policies completely bypassing that standard verification. This means you get blazing fast, near-instant policy updates. Of course, because Junos isn't validating these specific changes for you, you absolutely must verify your work first. But for agile, on-the-fly BGP manipulation, this is an absolute superpower.
Finally, Section 6, monitoring and troubleshooting. Basically, keeping the engine running smoothly.
If your muscle memory is totally dialed into other vendors, this part is basically your cheat sheet. Clearing counters becomes clear interfaces statistics. Checking your ARP cache, just drop the IP part, it's simply show ARP. And since we're operating in a modern vendor-neutral Layer 2 world, instead of CDP, you're going to be using show lldp neighbors to discover adjacent devices. These are your everyday go-to tools to verify that those active routes the RPD installed are actually, passing traffic like they're supposed to.
Beyond just individual commands, you really have 3 distinct ways to monitor your device's health. The primary method is, of course, the CLI. You'll use commands like ping rapid, which is awesome because it fires off the next ping immediately upon receiving a response, along with all your standard show commands. If you're someone who prefers a more visual management style, the JWeb GUI is a fully capable web-based alternative. And for massive enterprise-wide monitoring, Junos packs a super robust SNMP software agent that supports MIB2, traps, and version 2 notifications to feed right into your central dashboard.
All right, let's lock in the key takeaways from today. The RPD process, that is the indispensable heartbeat driving your routing tables without burdening the forwarding engine. You definitely want to isolate your management traffic using that MGMT-Junos VRF, but remember to meticulously translate your static routes over to that new instance so you don't lock yourself out. When you're ready to scale, lean heavily on the SPF algorithms of OSPF and ISIS for your internal networks and BGP for the outside world. And finally, if you're managing heavy BGP transit, that dynamic database is your golden ticket to lightning-fast policy commits.
Before we wrap up, I want to leave you with a thought to really chew on. Knowing that the Junos dynamic database can completely bypass standard verification overhead to give you those incredibly fast BGP updates, how will you redesign your own routing policies for maximum agility without sacrificing the core stability of your network? It's a massively powerful tool, but it definitely requires a masterful architect to use it right. Thank you so much for joining me on this explainer. Get out there, get into the CLI, start experimenting with these hierarchies, and keep exploring.